welcome everybody. Appreciate you taking a little bit of time out of your day to talk about the title here today is Empowering Your People with Automated Fabrication Systems. We're gonna discuss robots again. Had a lot of discussions about that. I'm here with David Zabka.
Hello everybody. And then with us today we've also got Gordon, Sales Manager with AGT Robotics, and we can't see him yet, but he's going to be joining us for the Q&A at the end here. Louis DeCare will be available for some Q&A at the end. Gordon, did you want to tell us a little bit about yourself?
Sure. Thanks, David. Yeah, I'm responsible for the sales of AGT's structural steel solutions here in the U.S., based out of the Dayton, Ohio area. And I guess in terms of qualifications, I sold my first arc welding robot 40 years ago. So to those in the audience that think this is newfangled technology or something that's just come about, we've been doing this for a long time. I'd also like to point out I was 12 years old when I sold that machine 40 years ago. So just in case you're wondering.
And that's a good segue. You know, David and I have work with a ton of fabricators, right? And we've been to a lot of association meetings. Just this year, since things have been ramping back up, I've tried to attend as many as I can. And without question, robots and robotic welding and machines in fabrication has been part of the discussion or part of the meeting. And there's certainly, it's a good volume of work out there today. And employee time and talent has been an issue for a lot of manufacturers. And how they're trying to solve that, right? So you're trying to improve throughput with not reducing quality and even maybe improving quality. And the advancements as being a BIM modeler software and how we handle welding and cutting and all that stuff, and the advancements we've had on our end and seeing what's happened in the robotic world has been pretty exciting. And there's just so many ways to handle it on what you want that machine to do. I mean, David, what else have you seen?
Yeah, you know, honestly, when I started working with SDS2 over 16 years ago, the discussions have always been the same. Good welders are hard to find, right? So it's an ongoing issue, always has been. You know, the COVID pandemic stuff, that seemed to make things even worse, and with the amount of work going through, putting pressure on fabricators to get more work out, you know, and still have the same quality and everything. Robotics has become a very popular topic here. I know I was at the FabTech show, let's see, that was last fall. It was November. It kind of actually prompted some of these webinars that we were doing because it seemed like every fabricator I had a discussion with, their main goal at that show was to gather more information, collect more information about some of these robotic welders and assemblers and the structural.
For sure. And so, what's been interesting for me as I've walked the path with our customers, even at times, having been in the industry over 30 years, is the different implementations and what kind of problems that causes for data and models. But you know, whether we're having the machine lay it out or we're having to do it welding, or what are we going to have that machine do, and what moves the needle the most for me. So I'm interested today to just hear these guys talk about how they implement their system.
Yeah,
so with that,
yeah, absolutely.
Go ahead.
Yeah.
No, I was going to say that you're absolutely correct, and it all starts with your product, right? Up until the time that we had the BIM modeling available and real CAD programs to detail buildings, we didn't have the tools available for the robotics industry to be able to program the products that our customers want to weld. So that's been an exciting development, and it came just in time for the huge labor crunch that we're all suffering through right now.
So let's take a look at how AGT does their implementation of robots.
Absolutely, we'd be happy to. All right. Whoops. Fast on the draw there. So again, thanks everybody for showing up today and for taking some time out of your busy schedules to learn about AGT's solutions for structural steel. And today we're going to be talking about two specific solutions. One is our LAYOUTMASTER solution for augmented reality in fitting, and our robotic welding system for structural steel of the BEAMMASTER. First, I'm going to do a short introduction of AGT Robotics. Who is AGT? Well, AGT is a group of talented professionals located in Trois-Rivières, Quebec, and also in Montreal, Quebec. And their purpose in life is to make robotic welding available to fabricators of all metal products. That includes not the typical high volume, low mix applications like automotive, but really we've been focused on high mix, low volume solutions for people in the general fabrication industry and specifically in structural steel. And we created solutions that are dedicated really towards this high mix, low volume equation. We've got a very wide selection of work cell designs, from very simple systems for very small parts to very elaborate systems for very large parts. We've tried to create solutions that are affordable, not just based on their initial acquisition costs, but also on their ownership costs and on their ability to be redeployed for other applications in the future. Quick delivery, well, we'd like to think we have quick delivery, but with today's supply chain issues and current backlogs, that has certainly slipped. But by having pre-engineered solutions, we've tried to cut the time associated with non-recurring engineering and find solutions for our customers that can be delivered without that 8-week of engineering time in advance of the system build. Another feature of our systems is the open architecture. And what this means is that the system is open to be modified, and like a Tesla automobile, every time the software is updated, your system improves in terms of its capability in either productivity or quality or operability. So open architecture is one of the hallmarks of our system design. Support is another important piece because our customers are based all over the world, and so we want to make sure that we have the ability to support our customers in the right way and in the right time. So all of our solutions come equipped with free remote support for as long as our client owns the machine, and some of the best web-based tools in the industry to be able to talk your operators or your maintenance people through a solution in real time on the job. And last but not least is the ease of use. Our systems are designed in a lot of cases using artificial intelligence to ease the operation of the equipment and eliminate a lot of the drudgery that comes along with programming robotic arc welding candidates. Here's a quick look at some of our solutions. Across the top, you'll see our solutions for structural steel, the LAYOUTMASTER for fitting, and the Ocean Challenger and the AGT BEAMMASTER solution for robotic arc welding. The Ocean Challenger is marketed exclusively by Ocean Machinery, a single zone version of the BEAMMASTER we'll get into later. We also have some small pre-engineered cells called our motofill cells. These are used by clients in the ag and construction industry, as well as our customers in structural steel for things like miscellaneous metals and other small components. Our block series of work cells can be configured to very large work envelopes, and we indeed have customers in the structural steel space using these to weld large modular building bases and components as well. And we also have a series of dedicated work cells that are designed to weld components that go into structural racking, something that became very popular as the pandemic unfolded. Globally, we have over 1,000 work cells installed and running, and our primary install base is here in the US and in Canada. We also have systems that are installed and operating in Mexico and in Europe, Australia, New Zealand, and we also have a system operating in Japan. Currently, we are 85 plus employees based in the two facilities in Trois-Rivières and in Montreal, as well as a few here in the US, and we're always looking for new, good employees. So with that introduction, I'm going to start into conversation about the LAYOUTMASTER. Again, our augmented reality solution for structural profile assembly. So unlike some of the other solutions you may have seen, we are not using robots to populate components onto a main profile. Material handling isn't the challenge for most of our customers. In fact, we've been told the biggest challenge in fitting is finding people that know how to use a measuring tape and how to interpret a drawing. So we looked at the solution from a different way. Let's reduce the skill set requirement but maintain the flexibility that a human brings to the table when it comes to the fitting operation. And that's what drove the development and creation of the LAYOUTMASTER. What is a LAYOUTMASTER? Well, it's essentially a high-power, full-color 3D laser projector mounted on a precision linear rail that's going to present the details of the fitting requirements taken from your SDS2 software package. It's going to project them on the main profile in a way that the operator can easily determine where he needs to put what profile, get it located accurately and quickly, and tack it in place. So essentially the job here is to eliminate all of the labor overhead associated with laying out or measuring your main profile to populate it with the components. In addition to the LAYOUTMASTER projector and its ancillary components located up here in this canopy, and the precision linear rail here, we also have an operator station which contains this industrial touchscreen tablet. This is where you will do the initial configuration of the LAYOUTMASTER system itself. And it's also a reference point for the operator to be able to review a drawing if he needs to, if he wants to look at it, or to call up the next product that needs to be to fit. And what he's going to use day to day in the process of fitting a beam is this 8-button remote control. Basically, everything he needs to know, everything he needs to do is located on this remote. And I maintain that anybody that knows how to use a smartphone is capable of using the LAYOUTMASTER and this control. And I think everybody is sure that the people on their shop floor can use a smartphone. So, how does it work? There's essentially 3 steps involved in fitting using the LAYOUTMASTER. The first step is really to take the information from your SDS2 software package, import it into our Cortex software, and it's going to create the projectable information. You're going to set your beam profile in place somewhere within the projection area of the LAYOUTMASTER. It doesn't necessarily have to be precise, but in terms of, in the interest of speed, if you can have the component located within a few inches of a datum location, that's going to really help. Then the operator is going to project the registration information. He's going to use this to align the projector with the profile. So you can see here with this series of yellow triangles. And this is the projected information. This is not painted on. This is actually the laser projection as it hits the surface of the material. He's got the datum end located. He's got the side edges of the flange located. Whatever information is required to orient the projector to the main profile for the first face to be fitted, this is where this is being done. He very simply jogs the projector to make everything line up with his beam. Once that's done, he pushes the button on the operator control to say next accessory. And you can see here how the information for the location of those accessories is then projected not only onto the workpiece, but also onto the accessories themselves. So we can see the landing point for these components, as well as the 3D images showing where the other lines should be in the real world. Once he's got that information, he simply tacks the component in place and moves on to the next one. The kinds of information that we can project include, as we saw earlier, the information required for locating and registering the main profile, whether that's a W profile, an angle, a channel, or an HSS tube. It doesn't matter. We can produce all of those edges and details in the projection. We can also project holes, either holes that are are shown or hidden holes to give reference information for the operator. In terms of connections, we can show where the connections actually land on the main profile surface. We can show connections on connections, something that would be very difficult to do in the real world using a drawing and conventional measurement techniques. And as we saw, we can also show all the edges of all the profiles to make sure that we've got very, very accurate placement of those components on the main beam. Hole information, we can show the location of holes, we can show center lines of those holes, and we can also show center lines of hole patterns for, again, for accurate representation and reference information. In addition to all that, we can show detailed part information. So this is going to really help the operator make sure that he gets the right part in the right place. So we can show information like a part number, a description of the part, dimensions of the part, and even the physical weight of the part to make sure that the operator has all the cues he needs to make sure he's got the right component in the right place. We already saw a little bit of the alignment tools, but as we move the projector down the line to project over your physical workpiece, the typical viewing window is somewhere on the order of 6 to 8 feet wide. So if we're looking at a 50-foot profile, we'll need to move the projector a few times to be able to get all the components fit across that entire length. So as we do that, we use a fixed array of red lasers that are always showing on the workpiece, and we simply use a calibration method here with the projection of 2 green lines to straddle those red lines. Once the operator's done this, it's an operation that takes about 5 seconds. He then has the projector registered for the next segment along the beam. And last but not least is the ability to project welding information. This is really important if you're going to use the LAYOUTMASTER in conjunction with the BEAMMASTER. In this case, we can show the operator welds that might not be achievable by the robot due to some issue like interference or it's an unsupported weld type. This lets the operator then perform that weld during the fitting sequence so that it doesn't have to be done after the robot has finished welding. Ideally, our goal here is to have the part fit in any welds that the robot can't undertake on its own, have them completed, so by the time a part comes off a robotic welding cell, it can go directly to paint. All right, I've got a little video here that's going to show a customer installation and show a beam being fit using the LAYOUTMASTER. My apologies for the long, slow-paced AGT introduction. I promise we'll make it worth your while. Okay, here we see a LAYOUTMASTER being used in a customer shop. Basically, profiles are being presented on trestles. And an interesting capability of the system is the ability to lay out some of the accessory parts, in this case an end plate. The customer was able to lay out the center line for the location of the web and also the top line where it's going to hit the flange, and he didn't have to use a drawing or refer to any measuring tape. He just did it all with the LAYOUTMASTER. Now he's got that in place. He's already gone forward with locating and tacking the gusset. He's got an angle plate here. And again, all he's doing is pushing the button to say next accessory on his remote control. The projector is then identifying the location for that, projecting the information for that assembly, and he just has to get it located between the lines, tack it in place, and move on to the next one. It's a very, very simple, very fast operation with, again, lots of visual cues for the operator to be able to use to make sure he's got the part in the right place at the right time. This operation, where he's welding this angle in place, I actually saw him in a previous version of this video where the tack shrank and pulled the part out of place. He was able to visually see that because the entire component was highlighted by the laser projection. He basically knocked the tacks off and retacked it in place in the right position. So a great way to make sure that you are sending properly fit components to the field. And he just works his way down the beam profile until he has accomplished all of his fitting requirements. And that's pretty much it for the LAYOUTMASTER. And so we'll jump right into the BEAMMASTER at this point. The BEAMMASTER is AGT solution for robotic welding in structural steel. We're kind of proud of the BEAMMASTER in that in 2019 we were awarded the Global Innovation Award by FANUC Robotics, our robot supplier. FANUC is the largest supplier of robotic welding or industrial robots to the planet. And we were awarded this Global Innovation Award based on the unique capabilities of the BEAMMASTER to take the details from a CAD detailing package like SDS2 and translate that into robot path and robot welding parameters without the need for any human intervention. Here's a quick video showing the BEAMMASTER at work. Essentially an industrial robot, welding robot, equipped with a welding package on a long linear rail and a set of movable rotators that allows us to present the customer parts in the horizontal plane for welding. So what is the BEAMMASTER? Well, as you saw in the video, again, we have a FANUC industrial robot equipped with a Lincoln 450 amp power supply, mounted on a long floor-mounted linear rail. It allows us to access long lengths of components and also allows us the ability to work in 2 zones, as we'll see as we move forward. And the robot is supported with a set of rotators, which allow us to clamp profiles up to 20 inches in the flange dimension and 48 inches in the web dimension, and a total of 10,000 pound payload per pair of rails. We have one of these rails is fixed, and it is the datum rail. Sorry, one of the rotators is fixed, and it's the datum for the beam welding. And the other rotator is located on a movable rail, which allows us to reposition the rotator in order to accommodate shorter or longer lengths of beam profiles. But it also allows us to move the rotator if our Cortex software package finds that the clamping is going to interfere with an accessory that needs to be welded. This is a typical configuration for the BEAMMASTER. As I mentioned, 2 zones, which allows the robot to work unimpeded in one zone while an operator is unloading a welded part and reloading a fresh part to be welded by the robot when complete. In this way, the robot is constantly working and we're not waiting for an operator to be loading or unloading components. There are 4 pretty simple steps to operating the BEAMMASTER. Number 1 is the export of your CAD details to our Cortex software. It's essentially a few mouse clicks to set up the export format, and once you hit OK, it's exported to Cortex, which then is going to, in this case, we're showing exporting an entire building, and that can be done in 1 click. The entire, all the details from that building can be exported at once, and Cortex will go to work analyzing the beam content of that building and starting on creating the welding programs. The operator then is going to select one of those programs from a drop-down menu on his operating station. He's going to pick one that matches the assortment of beams that are lined up to be welded. He's going to load that beam, and he can do it either vertically, as seen here, with the rotators oriented in this direction, or he can load it horizontally with a combi lift or forklift or a horizontal conveyor as well. Once he's loaded it up and clamped, the robot is going to go to work. As I mentioned earlier, all of the welding is performed in the horizontal plane, and that's what we're using the robot to orient the part on four different faces during the process of welding the component. So what makes the BEAMMASTER really unique is AGT's Cortex solution for no programming. Cortex is a software package we've been developing over the past 10 years to be able to automatically generate the programs that a robot needs to weld one-off components if required. And in this short slide transition, we'll show you how that works. So again, we're going to automatically analyze the entire building. Once the export from SDS2 has been made, we will identify all the unique parts in there. We'll discard any parts that don't require welding, or that are too small or too big or too heavy to go into the BEAMMASTER. But once we have selected the appropriate candidates, the robot goes to, or sorry, Cortex goes to work to start generating simulations for all of the parts in that building. And you can see here, this looks like a sped up video, but this actually represents the simulation process the robot goes through to create the robot paths and the welding parameters. Essentially, it's doing in minutes what it would take us many hours to do by conventional methods. Once it's done, it's going to generate these point clouds, these collection of positions for every beam in that building, and it's going to create a real-time simulation that you can view after the program's been generated. But these programs are what is uploaded to the robot controller, and the robot is going to play back in production. This also makes sure that we have a good idea of what the real time is going to be to weld a part prior to actually producing it. So we talk about Cortex as the no programming solution. No human required, no problem, really. So as opposed to the easy program solutions or offline programming solutions you may see out there, we feel that Cortex represents the only true no programming solution. And this is important because we don't want you to trade a skilled welder for a skilled robot programmer. We're hoping that we know that we can teach your existing resource to be able to use the system effectively and capably. So the progression in terms of programming has been from manual programming, where we're using a teach pendant to program point by point, to what we call assisted programming or lead-through programming. This is being used on smaller parts where you might have repeats of 6 to 10 or 20, where the programming time investment is worth it. Offline programming takes the programming requirements from the teach pendant and puts them into a computer somewhere at a desk outside of the robot work envelope. And this is great to allow the robot to continue to work while you program new parts, but it isn't much faster than the manual programming method, so it's still a laborious process. And then we have Cortex programming, as we described earlier. It's autonomous programming. Basically, a software program is doing the programming while you go home and have dinner and go to sleep. Essentially, you can load up a building's worth of details at 4 o'clock in the afternoon, let Cortex chug all night, and in the morning you'll come back and have the next 2 weeks' worth of production programmed and ready to go. And there's also, you can see grayed out here, autonomous online programming. That's being worked on. It's being touted as a viable solution for some applications, and sometime in the future it probably will be. Today, we feel Cortex represents the best solution for no programming. So now we're going to talk a little bit about fitting and welding. What happens when you combine the two and create a complete fitting and welding solution? So when you add a LAYOUTMASTER to a BEAMMASTER, you end up with an integrated fitting and welding solution that can allow an operator to do the same kind of work as up to 8 fitters and welders. So the two systems work in conjunction together to make sure that one operator is able to produce the fitting requirements, the robot's generating the welding requirements on a single shift of between 6 to 8 operators. Here's a little video that's describing how this works. The operator sets the robot in motion in the left-hand zone while they go to work on the right-hand zone to do the fitting. So they've loaded a raw profile in the rotators. They're now matching the stiffeners and clips, whatever end plates, whatever accessories need to be tacked in place using the LAYOUTMASTER while the welding is going on in the other zone. Another advantage of this solution is that you've reduced non-essential material handling a great deal because you only handle the main profile once from the time you load the raw profile on the rotator until the time the robot has completed the welding operation. So significant reduction in material handling time. Once the fitting operation is complete, the LAYOUTMASTER and the robot exchange ends and go to work in opposite zones. The two systems are designed to be modular and to work together as standalone solutions or be augmented in the future. So for example, you can start out with a basic BEAMMASTER solution without rotators and just do your material handling manually. You can add rotators to create the automated solution we saw in the video. You can then add a LAYOUTMASTER to give you the ability to do layout and robotic welding in the same zone, the same solution. And if your parts are long enough or welding intensive enough, you can add a second robot to virtually double the output of your system. Again, the systems are designed to be modular, so you can start with a LAYOUTMASTER on its own, or you can start with a BEAMMASTER on its own and add the other system at a future date as required. So in summary, we feel there are 7 really good reasons why a structural fabricator should consider one of our solutions for structural steel. It's a simple solution. The technology is easily understood by your existing resources, both from an operational perspective and a maintenance perspective. It's proven in customer shops around the world with over 70 sales to date. Don't just take our word for it. If you look on LinkedIn, you'll see plenty of posts from our customers that are bragging about their welding quality or about their productivity. And I think this should have been the #1 reason, no programming. This is really what makes our solution significantly faster and easier to use and unique in terms of the other solutions on the market today. By giving you the ability to take your CAD details from SDS2 and automatically create robot programs and robot welding parameters, it's a significant competitive advantage for you. Productivity, which is pretty much the same for all robotic welding solutions. You should be able to generate high-quality welds with any robot, and you're going to find that you are 3 to 5 times more productive with a robot than with a conventional manual welder. And it's not because the robot welds faster than a human, it's because the operating factor of a robot is much higher. Robots are going to weld at rates 3 to 5 times greater than your human. And as you can see, the weld quality is repetitive and high in quality, and you can do some pretty significant and interesting things with multi-layer welds as well. The BEAMMASTER solution is also very versatile. So not only can it handle mill profiles in terms of W profiles, H-beams, HSS tubes, angles, channels, but it also can handle fabricated beams, whether they're straight or tapered or have dual tapers. So a very popular solution for our clients in the pre-engineered building world. But in addition to that, the BEAMMASTER is also a conventional welding robot on a rail. So we have helped clients in the structural industry to weld other assemblies that may be structural in nature, but don't necessarily fit the operating envelope of our positioners. In this case, a client used one of our BEAMMASTER solutions to weld a series of I-beams onto a deck plate, saving him over 20 hours of welding time per assembly. So it may not be programmed fully automatically, but again, it's a welding robot, and we have helped customers to create automated solutions for some odd weldments that come through their shop. The BEAMMASTER LAYOUTMASTER combination is really an automation solution that's optimized for floor space. And when we look at our customer shops today, we see that not many of them have wide open spaces waiting to be occupied by very, very large welding systems. So we occupy about 1/5 of the floor space of some of the typical systems that are seen out there today. And within that floor space, again, if you're using a combined system of a LAYOUTMASTER and a BEAMMASTER, that floor space is generating the same output as 2 fitting bays and 4 welding bays. So it is very space effective. And last but not least is service. Don't trust us, ask our customers. AGT prides itself in having world-class service. Again, great tools to communicate with your team in real time online, to talk them through the issues they're having with the system. And also great documentation, which is always available to your team because we have it published online. It's not going to be locked up in the maintenance supervisor's office at night when somebody needs to refer to it. It's always available to the operator on the HMI or on a computer someplace, ready to be accessed when required. And that brings me to the end of our formal presentation.
Thanks a lot, Gordon. I appreciate it. Very informative. Your 4th reason slide that had that all the weld passes, it amazes me at how many times fabricators are put in that spot. And you really, the thing that's interesting is, that you can grow with the customer and the adaptability of what they're trying to do, and grow into the system instead of having to do everything at once is certainly valuable too.
Yes, yeah, exactly. I mean, I can assure you that everyone that has a BEAMMASTER solution in operation has found that every year with each software upgrade, their system becomes more capable, more effective.
Very good. Yeah, Doug, I laughed when I saw the multi-pass weld there on that slide as well. I thought the same thing as you. So it always amazes me to see welds like that, just in general, but then to see the capability of the robots to be able to do that now, and the way that they've progressed over the years is impressive. Yeah, I've got kind of a question here. So, as we're going through this stuff, and this is all great, I might have a question about, what prompts a fabricator to go with, say, the LAYOUTMASTER versus scribing? What are the benefits of a LAYOUTMASTER versus doing actual scribing on that steel?
Yeah, and it's a good question. And we have BEAMMASTER users that have elected not to use a LAYOUTMASTER because they have scribing capabilities on their coping system or on their drill line. And I think it's a matter of capacity. These days, a lot of our customers are maxed out on capacity. They're trying to handle some pretty impressive increases in volume. And using your drill line, which is really good at making holes and coping and doing all those hard operations, to do scribing sometimes isn't the best use of that equipment. So they can actually add capacity to their drill line by incorporating a LAYOUTMASTER and taking that scribing function off the shoulders of their drill line or off their plasma coping system. So it really depends on the skill level of your operators, and it depends on the upstream capacity you have for marking your product.
Great. Yeah, perfect. Okay. One thing that we should probably touch on a little bit that we hadn't really discussed too much is the Cortex software, correct? That's the operating software there. So I know we can get information from SDS2 to that Cortex software. That's via IFC file. Is that correct, Gordon?
Yes, that's correct.
Okay. And do you know if is there anything special about that IFC file? Anything we need to do on our end to make sure that information is getting transferred properly over to the Cortex software? Just ensuring that the format box is checked correctly to make sure it's coming out in, I think it's an EM11 format. Okay.
And once we have that, all the information we need in terms of material properties and the joint locations is there and ready to read. Perfect.
That's great to know. I know SDS2, we were involved several years back when AISC, that was a big initiative to come up with that EM11 IFC format to make sure that all the information from our BIM softwares are getting transferred over to the fabricators properly and had all the information in there to be able to run the machines like this. So yeah, we got that EM11 in there on the export from SDS2, and then Cortex should handle it from there. That's good.
Yeah, absolutely. Yeah.
All right.
That's kind of it for me, I think. So.
Yeah, I agree. I just, again, that slide, I pity the soul that had to do it manually. We're letting welding robots do what they're good at as well. So I think we'll go ahead and ask your questions as you have them. We'll go ahead and look through them, answer them as we can. So we'll give you a little bit of time to do that, and then we'll start answering questions. Again, want to thank everybody for attending.
Yeah, thank you.
So we do have a question here about the kind of playing off of the IFC files here a little bit. So one of the questions is about the welding information in the IFC files. So we talked about, using the IFC file. We talked about the EM11 format that's needed coming from SDS2. But the question would be if that welding information isn't included in the IFC file, does AGT, does a Cortex software, does that have the ability to kind of figure out that welding information if it's not in the IFC file?
It does. Do you hear me?
Yep, we hear you great now. So
okay,
we had
perfect.
A couple technical difficulties there, but we got over them here now, I think. So
yes, it does actually. Probably 85% of our customer are using the auto-generated welds from Cortex. So it can generate where to weld and what to weld, and obviously the how to weld is always Cortex. So it uses, typically you can still customize basically what you need in order to match your production. So in the first steps when we install the software, our application engineer will go with the customer and kind of generate the general guidelines or rules, including the thickness. So typically our customer will use the thinnest plate as the reference, but they have control on exactly what weld to generate automatically. So short answer is yes.
Okay, great. So I would imagine, so, on the SDS2 side, one of our big kind of factors that separates us from our competition is the connection design. So I would assume then that, on the flip side, if that information is in the IFC file that we provide, it's going to go ahead and just use that then, correct?
Correct. Actually,
okay,
we have three modes. We have we don't listen to the CAD mode and we auto-generate it. We have the mode where we only listen to the CAD, the IFC files. And the third mode is a hybrid. So you could decide to automatically generate most of the weld, except if there are exceptions, basically, and then it will override whatever was generated automatically for some reason.
Okay, great. That sounds, that sounds really great. Sounds like pretty flexible in that, so that's all very good. Couple other questions in here. So, one of them has to do with probably maximums or limitations of the machines here, it sounds like. So talking about, what's the maximum beam size that the BEAMMASTER can accept, or is there limits to the length of the materials that it can accept, things like that? And I apologize if that was covered in the presentation there. Maybe we missed it, but if we could repeat that information, if it is a repeat.
Sure. Do you want me to handle this one, Louis?
Go ahead, Gordon.
Okay. All right. Well, I don't think we covered the exceptions in the presentation, so it is a good question. Thanks, David. So the standard system has a capacity of a beam profile with a 20-inch flange dimension and a 48-inch web dimension. And the length is really variable depending on how long you specify the effective welding zone for each zone that you're going to be working in. So typically a standard solution can weld parts up to 34 feet long, but we have clients that have specified systems that get up into the 50-foot long section in each zone. Occasionally we have clients that have assemblies that are longer than that. So if you're trying to weld a 60, 70, or 80-foot component, you can simply bridge the two single zones together to create one super zone, and then you can span those two zones and let the robot work across them to weld very, very long columns or very long beam assemblies. By doing that, you also increase the payload capacity of the rotators. Each one is capable of handling 5,000 pounds, or a total of 10,000 pounds per zone typically. But when you open up those two zones and create the super zone, then each rotator that you add gives you another 5,000 pounds of capacity, so potentially up to 20,000 pounds of payload.
Great. So recap on some of the maximums there. Then I think I gathered 20-inch flange width is the maximum on the flange width, and a 48-inch on the depth. Then is that correct?
Yeah, that's correct. That's what you can fit into the rotators themselves. You can also, I mean, the BEAMMASTER is still a robotic welding system, and if you can physically put an assembly in front of the robot and the robot can reach it, then we can use more conventional means to actually weld that component. You won't be able to rotate it automatically in the rotators, but if you can access it with the welding robot, then we can organize to weld those assemblies as well.
Got it. That makes sense. Very good. And then here's another one about multi-pass welds. So I think we saw a slide in there with a pretty large multi-pass weld, right? We commented on that already. I laugh when I see that stuff. So you are able to handle some multi-pass welds, then, correct?
Yes. So the easy multi-pass would be 2-pass and 3-pass. So when you specify, I was talking about the chart earlier for auto-generated weld. So if you specify, for example, then it's a 1/2 inch weld, the system will automatically generate a multi-pass path and recipes for the weld schedules. So that's automatic. If you want to go to preparation and full pen, then it's a semi-automatic. For now, our goal is to make it fully automatic in the future. For now, we'll have to kind of indicate to the robot the route start, the start of the route pass. And then it'll be autonomous for the passes in this one or so. Yeah.
Very good. Very good. How about, here's a question, and this may go back a little bit to what Gordon was talking about with laying. If you can get a conventional part in front of or maybe unconventional part in front of the robot, we ought to be able to get it to weld it. Do you have anything for rails? So if I'm doing handrail layout or anything, are we able to do anything with rails and get rails welded with this?
Yeah, we do have some clients that are looking at using the LAYOUTMASTER to do the actual projection of a layout for a railing section or stator stringer or any of the miscellaneous metal components that they've got. Using the LAYOUTMASTER to actually project that information and assist their fitter with laying out those components. And I mean, some of those can be pretty laborious fit-up jobs. So if you can reduce the time to measure and you can use the LAYOUTMASTER to be able to confirm that everything's in the right place, then it's a big help. So we are seeing the LAYOUTMASTER being used now on the miscellaneous metal side. And from a welding perspective, though, it's still not something that we don't have a solution. The BEAMMASTER is not a solution to weld miscellaneous metal components like a railing section, and nor do we have a fully automated programming solution for that. But stay tuned. There's lots of that going on, and it's also a very challenging thing to try and weld.
Well, hey, if we can get the layout, we're one step closer, right? And I'm sure
Exactly.
someday some things will come. So technology is always advancing. So yeah, someday. How about? So yeah, here's another question. A little bit about kind of some maintenance. What do we see for maintenance costs on the LAYOUTMASTER and the BEAMMASTER? Any idea, or can we provide any sort of canned response on what that sees? Because I'm sure it fluctuates depending on how much it's used, and it's a machine, so parts can fail, everything can go wrong no matter what machine you're using. So what do you typically see for maintenance costs, I guess?
I can address the BEAMMASTER situation. The BEAMMASTER is going to be like any other piece of welding equipment in your shop. Your day-to-day maintenance requirements are going to be the same as your manual welding equipment. So the same consumables, contact tips and liners and nozzles, they'll all need to be maintained, probably lasting quite a bit longer than they do in a manual operation, but they still need to be maintained on a daily basis. The robot itself is an incredibly reliable piece of equipment. I think today's stats are somewhere in the 100,000 hour range, but mean time between failures. So aside from an annual inspection and lubrication of the robot and the robot rails, precision rails, there really isn't much to go wrong. Again, it's going to be more associated with the process, with the actual welding consumables and the points that touch your welding process than anything else. I'd say there's always the danger of a inadvertent impact if a part is misfit or in the wrong place. Then those kinds of things can happen, but they're easily resolved with really a very modest supply of spare parts. So the maintenance cost and the spare parts cost are really not a major consideration in terms of the machine's operating cost.
Okay, good to know. Good to know. That's good info. And then the last question I'm seeing on here is about, can you talk about how you are providing or managing CWB qualifications for programmers and operators? Any info to provide on that?
Okay, Louis, do you want to jump in on that one, or do you want me to handle that?
Yeah, I can. So,
Okay.
Well, typically, so we have a welding engineer that works with us. He knows exactly, he's actually involved on the CWB board. So typically, we need the equipment. So the BEAMMASTER needs to be qualified, and typically it's a pretty straightforward procedure where it will weld 1/4 of an inch, 1/3/8, 1/2 an inch weld. You bring in the CWB guys, and pretty much off you go. Once the equipment is qualified, any operator can use it. Same thing actually, also in the U.S.
That's good. So essentially the inspector's got to come in after the machine's all set up, ready to go, inspect some of the welding that machine's doing, and make sure it meets all the qualifications. Then, is that correct?
Exactly.
And so would that have to be done? I mean, does that have to be done once a year, twice a year? Every 5 years? Is there a time frame that that typically has to be done then, or is it just a one time and everything's good after that?
Good question. Do you know the answer, Gordon? I think it's the same concept as a normal human welder on the shop floor.
Okay.
I'm not sure if it's annual. There might be some refresh after a certain number of years, but fully aware of that. Yeah,
and I think that could differ between U.S. and Canada, but again, anytime you change operators or anytime you change welding procedures, there'd need to be a requalification procedure. That frequency will be determined by whatever the inspection agency is.
Okay, great. Well, we had some good questions, had a lot of good information in here, so it looks like we're coming up on the end of the questions. Perfect timing here and in our hour time box. So just thank you guys here, Gordon, Louis, appreciate your time. Want to thank everybody else that attended here today and watched. Hopefully all this information was useful. And yeah, look forward to seeing everybody on the next webinar here.